Assalamualaikum warahmatullahi wabarakatuh. My name is KHAIRULIZWAN bin OTHMAN. I will present about dissociation constant estimation using acetic acid and sodium hydroxide titration. The objective of this experiment are to determine the molarity of acetic acid. Second, to understand the endpoint and the equivalent point of titrimetric analysis. Third, to calculate the dissociation constant. We move to the next part. Titration. Titration is a process that is common laboratory method of quantitative chemical analysis to determine the concentration of an identified analyte. Base that is chosen is sodium hydroxide. This base was placed in the burette. As for the analyte, acetic acid was placed in the conical flask. During the experiment, this titration progress can be monitored by indicators such as phenolphthalein or by using the litmus paper. The phenolphthalein is pink in base solution and colorless in acidic solution. This indicator is used to signal the end of the reaction, which is the endpoint. You can look at equipment setup picture. One of the goals of this experiment is to determine the equivalent point of titration, which is the point in titration. The addition of an indicator to the analyte solution helps to visualize the equivalent point for an acid-base titration. The result we get from the equivalence point will be used to calculate the acid dissociation constant of the acid being titrated. This formula is used in this experiment. Okay, for the methodology part. Part A, standardization of acetic acid, and part B, determination of acetic acid. For part A, 10 milliliters of 0.01 mol acetic acid solution was added into conical flask, followed by 50 milliliters of distilled water and 4 drops of phenolphthalein indicator. The entire solution in the conical flask was titrated by 15 milliliters of 0.05 mol sodium hydroxide solution. Use burette until it changes from colorless to very pale pink. The volume of sodium hydroxide required to change the color was recorded. The molarity of the acetic acid was calculated. For part B, determination of acetic acid. 10 milliliters of 0.01 mol acetic acid solution was added into conical flask, followed by 50 milliliters of distilled water and 4 drops of phenolphthalein indicator. A small amount of sodium hydroxide was added. The pH paper was inserted. The solution was let equilibrate. The entire solution in conical flask was titrated by 50 milliliters of 0.05 mol sodium hydroxide solution until the color changed from colorless to a very pale pink. pH against volume of sodium hydroxide was recorded. Titration was continued until the pH reading remained relatively constant at pH of 11 and 12. As you can see, this is the result of this experiment for part A and part B. Discussion. The Arrhenius hypothesis is used in acid and base titration. We employ phenolphthalein as an indicator. The titration has been complete when the color changes from colorless to light pink. Between the indicator and its conjugate base, a balance is achieved. The equivalency point is the point in the titration flux where the content of hydronium ion and hydroxide are equal. The neutralization reaction is complete at this point, with no extra acid or alkali. Only salt and water are present in the solution. The pH of the solution remains constant after 11 ml of sodium hydroxide is added until 25 ml of sodium hydroxide is added. The last part of this experiment is conclusion and recommendation. This experiment is related to the dissociation constant and it attempts to compute the dissociation constant and graphs the endpoint and equivalent point of tetrametry analysis. After conducting this experiment, we can conclude that acetic acid was a weak acid because based on the result and value obtained after did some calculation, the determination of dissociation constant of acetic acid in this experiment was reasonable. The major goal of this experiment was to comprehend the endpoint and equivalent point of tetrametry analysis as well as to calculate the dissociation constant, which was accomplished by getting the confirmed and valid value. During conducting this experiment, a few errors has occurred which affect the result, such as the solution may have been titrated too much and exceed the endpoint. The solution already turned pink, but the titration process still continues. By handling the burette with caution during the titration process, this experimental error could be overcome. Besides, during the preparation of the chemicals, make sure the calculation of each reactant was correct, so that the chemical need in this experiment were enough and the experiment can be conducted fluidly and the result obtained more accurate. That's all from me. I'm KHAIRULIZWAN by OTHMAN and my student ID KA 21052. Thank you.